Assalamualaikum warahmatullahi wabarakatuh. And good night, everyone. Can you listen again? Can you listen?
Boleh.
Okay. Okay, don't forget to tick your attendance. Okay, before we start with Al-Fatihah. Okay, this is week number 3. So in week number 3, you are going to learn about frame analysis using flexibility method. Okay, basically frame analysis have similar analysis just like beam analysis, except the frame is combination of vertical and horizontal element. So we still have to apply what we call as principle of superposition to and from that we actually produce the compatibility equation, and compatibility equation is actually displacement at redundant position. So we have to we will solve for the redundant by solving compatibility equation. Okay, same analysis except the structure is different. Okay, same formula as well. So for the displacement, we integrate moment equation. We integrate moment equation to get displacement. So most important, indeed this I want to highlight actually the effect from support settlement. Okay, and this effect from support settlement can also occur in beam, in frame, and in truss as well. Okay, so this is actually what we have in the module under topic number 3, frame analysis. Okay, so if we look at to the learning outcome, of course, I believe everyone have understand about the degree of indeterminacy and also redundant. So we determine redundant from degree of indeterminacy. The redundant has to be removed from the system. We need to determine redundant first, then only we can determine remaining reaction. So the redundant we will determine from by solving the compatibility equation, and the redundant that we need to determine, we have to remove. We have to remove first, and then by removing the redundant, we get the primary structure or primary frame, and one redundant has two system. One redundant has two system. Two redundant we have three system. Okay. So we calculate displacement. So formula displacement as usual, we integrate two moment equation. One is come from primary structure, primary frame, and another one is come from redundant frame. Redundant frame. One redundant means there is one redundant one. So if we have two redundant, we will have redundant number 2. Okay. Basically it is same, just like beam. Okay. So okay, we just go through this. Actually, I have uploaded the video, the link for previous from previous class. So it is actually the same. So let me go through this fast, and we will spend time to do another example. Okay, just like this, just another example. Okay, so this is one redundant frame. One redundant frame, remember, for flexibility method. Okay, so this frame, looking at this frame, based on the support condition, we have here A. Okay, we have roller at A and fixed at D. Roller at A and fixed at D. So there are 4 unknown reaction. And these 4 unknown reaction we cannot determine using equilibrium equation directly because one redundant in the system. Okay, the difference between unknown reaction and 3 equilibrium equation is 1. So we have to divide between 3 and 1, and we need to determine the value, the redundant value first, then only we can determine remaining reaction. So this value, this redundant value, we determine from compatibility equation. Okay, that's the concept. That is the main goal. We will determine actually the reaction in the system. Okay, so looking at this frame, this is indeterminate frame to the first degree of indeterminacy. One redundant is called as first degree of indeterminacy. The frame is supported by a roller at A and fixed at D. The frame is subjected to various type of loading. Okay, we will analyze this using flexibility method. Okay, and we need to consider the settlement. Determine the value of the redundant. This is the redundant. If support rotation at D is given as 1000 over EI counterclockwise, and we choose moment at D as the redundant. Okay, so support settlement actually has three types. Support settlement. Okay, all this is called as support settlement. All these three is called as support settlement. Whether it is support settlement normally occur in vertical direction, downward support settlement. Okay, if the movement is in horizontal direction, it is called as support displacement. Support displacement is also support settlement. Support displacement moving horizontally to the right side, to the left side, it is also support settlement. Okay, and we can also have support rotation. Support rotation, it rotates clockwise, it rotates counterclockwise. So if it is mentioned in the question, all these are considered as support settlement, having support settlement. And support settlement, we need to include into actual system. So we have to include in actual structure. Remember, we have the general equation, which is come from the principle of superposition. So we have actual structure is equal to primary structure plus redundant structure. Remember, this is same to beam as well. Okay, so having support settlement means actual structure, this value is not equal to 0, but it is equal to settlement given. Okay, you get what I mean? Okay, previously when we don't have support settlement, when we write the compatibility equation, it is like this: A B naught plus F BB BY is equal to 0. This is equal to 0 when there is no support settlement. No support settlement. Okay, same goes to theta. Theta A naught plus FAA times MA. This is equal to 0 when there is no support settlement. Now, when settlement is given or is mentioned in the question, means that this equation and this equation with support settlement, with support settlement, okay, this is not equal to 0. If, for example, delta B is given, for example, let's say delta B is given as 0.005 downward in meter. So what happened is delta B naught plus FBB times BY is equal to negative 0.005. So this means support settlement. Support settlement. So that's the only difference. Okay, and let's say if we have support rotation, one node F11 MA counterclockwise 1000 over EI. Okay, this is also support settlement. This is also support settlement. Type support rotation. Support settlement. Okay, whether it is positive or negative, it will be actually depending on on redundant diagram. Later on, I will show. Okay, so this is the example in the module, and please refer to the video. I have put the link, okay, in Telegram. Okay, so we will do another example tonight. So we add another one. So this is your OneNote class notebook. You can refer to this. Okay, now 5C1 frame frame 1 redundant. One redundant. Okay. Okay, we will try another example, another frame example. Okay, now we have three members of frame. Okay, let's say we do another example, one redundant. This Friday we will do two redundant. Okay. Okay, fix at A. Fix at A and roller at D. Roller at D. Okay, this is A, B, C, and D. Okay, let's say BC has UDL 25 kilonewton per meter. Okay, 25 kilonewton per meter. This is 2 EI. 2 EI. And then this is EI. And also EI. Okay, we apply another one, moment. This is 300 kilonewton. 300 kilonewton meter. Okay, distance. So let's say this is 10 meter. This is 4 meter. And this one is 9 meter, for example. Okay, so let's say this is the frame. This is the frame, one roller at D, fixed at A, EI, AB is EI, CD is EI, BC is 2 EI, 10 meter, the vertical, the height for AB is 10 meter, for CD is 4 meter, for BC is 2 EI. 2 EI and support settlement. Okay, support settlement at, okay. Support settlement, the best redundant is whenever support settlement and redundant have same point, have same position. For example, let's say theta at A means support rotation at A is given as 1000 over EI clockwise. For example, 1000 over EI clockwise. This is actually the support settlement. Support settlement given in the question. Okay, mentioned in the question. Okay, means that we, okay, always remember moment induced rotation. Moment induced rotation means that moment, the partner is theta. Same goes to delta, P delta. P and delta, moment and theta. Okay, moment and theta. So if the settlement or the support settlement is given in rotation, means that the best redundant is moment at support. Okay, we cannot simply choose dy as the redundant whenever rotation, the support displacement is rotation. Okay, so the best option is we need to choose MA as the redundant because theta A is the support settlement. Okay, so by choosing this, we can write the compatibility equation. Standard form. Remember, we use R1 is equal to MA. So what happened is we have theta 1 plus F11 times moment at A as the redundant, and this is equal to, this is actually theta 1 or theta A. So we get theta 1 plus F11 times MA. This is equal to the settlement or the rotation given at A. It is 1000 over EI. It is not equal to 0. It is 1000 over EI. Okay, this is 0. Okay, now this is the compatibility equation. We will solve for the MA by solving this compatibility equation. So our task now is to determine two displacement or two unknown here. Two displacement, it is theta 1 naught, which is displacement from 0 to L, M1 M naught dx. And we have another one, F11 is 1 over EI. 1 over EI from 0 to L, M1 square dx. So from this, we know that what we want is moment equation. What we want is M naught, and also M1. M naught is come from primary frame, and M1 is come from redundant frame. The redundant is redundant MA applied. Okay, so we will start analysis by analyzing reaction and then determine or writing moment equation for both M naught and also M1. Okay, so the redundant is MA, means we need to remove MA from the frame. So we will have two structure. One is the primary frame, and in primary frame we will get M naught, and we will get redundant. We will have another one. It is redundant frame. And from this, we will get M1. Okay, so the frame that we have is this and this. Same frame. Same frame. Okay, now support A, we change from fixed to pin. Fixed to pin because we have removed moment. So fixed become pin, remain roller at D. Okay, so between primary frame and redundant frame, actually it has same type of frame. Okay, for primary frame, we remain all external loading. So here, AB along member BC, and then moment clockwise, and the value is 25 and 300. This is 25, this is 300, 10, 10, 9, and 4 meter. Okay, so this is primary frame, just like real frame. Just like when you learn deflection, topic deflection, we have real structure and virtual structure. So just like that, similar. Not equal, but it is similar. Okay, so we have primary frame. It is determinate frame subjected to all external loading. We remain all external loading. The only one that we remove from the frame is only moment at A. So that is why fixed become pin. Okay, so remain all external loading. Okay, now we look at to the redundant frame. Redundant frame, it is just like a virtual frame. It is just like virtual frame, means that it is a frame, a determinate frame subjected to a unit value of redundant. A unit value of redundant. Redundant is MA, means that we have to apply a unit moment at A. A unit moment at A. Okay, if settlement given in the question is clockwise, here clockwise, settlement given in the question 1000 over EI clockwise means that we will apply a unit moment in redundant frame in clockwise direction. Clockwise direction. So this is a unit value of MA. So the redundant frame is just a determinate frame without any loads. It is just like virtual frame, but this time it is a unit value of MA. Kali MA tu of MA, a unit value of MA. So we have two system, primary frame, redundant frame. Sama tak ada beza langsung dengan previous, except nanti equation only, the compatibility equation only is not equal to 0 anymore because of the support settlement. The rest same. Okay, so we have primary frame, we have redundant frame. So using the distance given, we will calculate the value, the reaction at the support for both primary frame and redundant frame. Okay, please calculate it now. Please calculate for me the AY value. Please calculate this value, AX0, because there is no horizontal reaction, right? There is no horizontal reaction, so AX0. So please calculate for me this value AY for primary frame and DY for primary frame. The same goes to redundant frame. Please calculate AY for redundant frame and DY for redundant frame. Please calculate the value. Okay, please calculate the value. Or you can write the value. What is the value? What is the value for dy? Get dy first by taking moment at A is equal to 0. What is dy value? Come on, what is dy value?
One four
145.83. Okay, the rest you get the same. Okay, 145.83. So what is the value for AY? It is 25 times 9 minus 145.83. What do you get? What do you get? Cepat. Tadi saya nampak macam Afiq nak cakap. Tapi tak cakap pun. Okay. Cepat-cepat. 25 times 9 minus 145.83. What is the answer? 79.17. 79.17 Okay. Thank you, Arif. Okay, the rest please check Please check. So that is reaction for primary frame. For primary frame, isn't it? Betul tak? Okay, and then we calculate reaction at redundant frame as well. So it is 1 minus 9 dy. So dy is equal to 1 over 9 berapa? 1 over 9?
0.11.
Okay, sorry. My camera is not working well today. Kejap okay, kejap robot. Okay, 0.111 Okay. So we calculate reaction so that we can write moment equation. Okay, so we have to understand that reaction tu memanglah dia part of procedure. But kenapa kita calculate reaction? Because yang kita nakkan adalah moment equation. Because moment equation tu input kepada displacement. So reaction tu kita buat sebab kita nak tulis moment equation. Bukan sebab dia compulsory. Bukan sebab dia compulsory. Sebab kita nak displacement. Displacement perlukan moment equation. Moment equation perlukan reaction. Because ada some cases yang maybe we don't need to calculate reaction. By choosing the redundant from one side, for example, we don't have to calculate reaction. So reaction tu dia bukan compulsory. So dia jadi compulsory bila kita perlukan that reaction to write moment equation. Okay. So yang ni patutnya buat sekejap je lah, 5 minit. Not more than 10 minutes lah. Around 5 minutes, 5 to 10 minutes then okay lah. Kalau boleh cepat lagi bagus. Okay, and as usual reaction tak perlu tunjuk. Just have these two diagram dengan ada reaction. And after that, we write moment equation. So moment equation, we have to cut section. So 1, 2, and 3. 1, 2, and 3. Remain the same. Remain same. Same cutting section, same limit, same origin. Okay, same cutting section, same limit, same origin. Okay, this Friday, the first 1 hour tu kita akan buat latihan. Buat latihan. Lepas tu the next 1 hour tu baru kita buat satu lagi example untuk two redundant. Ada one lah sama ada yang tu dulu ataupun buat latihan two redundant ada. Tapi 1 jam tu kita akan hands on lah buat. Sebab saya nak tengok juga how you actually write moment equation. Sebabnya Serosu ada bagi tahu saya yang dia susah hati. Masih ramai student cannot write moment equation correctly. Dia mungkin cakap based on dia punya group. So saya nak you all semua boleh tulis the right moment equation. Okay. Because normally the problem for flexibility method is whenever student cannot write the right moment equation. Masih confused lagi about sign convention, about limit, about origin. Okay, make sure kalau you rasa you lemah yang tu, please do revision, do lot of exercise. Okay, latihan-latihan yang you all buat, please you boleh upload dekat dalam OneNote ni so that saya boleh semak. Okay, you boleh upload dekat sini ya. So you have your own folder yang mana saya boleh tengok semuanya sekali. Okay, and please upload whatever exercise yang you buat. You nak minta saya semak betul tak betul konsep, betul tak, you just need to insert, print out ya. Insert print out kat sini. Insert print out, then you boleh upload the PDF file. Okay, so let me know after that so that saya boleh check. Okay, you jangan biar saya paksa you upload ya. So please do exercise and let me know so that saya boleh check lah. Okay, saya boleh check you ada add kat sini macam ni, ada. Okay, should be ada submission kat sini. Ni ada submission. You just upload lah, just like this. Okay, so that I can check for you whether your understanding is correct or not. Okay. And don't worry, your friend cannot see yours. Okay, only me can see. Okay, go back to this one. Okay, we have 3 cutting section. We have A, B, C, and D. So we have A, B, C, and D. A, B, C, and D. And we summarize all this into table form. We list all the members. So yang saya highlight ni, yang important yang saya nak tengok during examination. Okay, bila you jawab tu, make sure semua-semua ni ada yang kat sini yang beri kita markah. Sini semua yang beri markah. So saya nak tengok all this the diagram for primary frame, redundant frame, and then the table, because the table consists of moment equation. Okay, in writing moment equation, we must decide origin, and from origin we will get limit. Okay, we have 2 moment equation come from 2 system. We have M0 and M1. If we have 2 redundant, we will have M2. Okay, but now we have M0 and M1 only. Okay, so for AB origin A should be the origin because it is the easiest section. CD origin D, again because it is the shortest and easiest cutting section. Okay, and for BC, okay, look like B is the easiest cutting section. Okay, we can also choose C as origin. B and C can be origin, but we cannot choose A and D as origin. For BC ni, we have choices between B or C as origin. But we cannot choose A as origin, we cannot choose D as origin. Because X moving in straight line. So bila kita cut section ni, X dia bukan jalan macam ni. Okay, X moving in straight line. So for member BC, X like this, or you can also have X like this. Okay, so ini kalau B lah, ini kalau C. Okay, and moment direction, please be careful. Okay, for example, if we choose B as origin, look at the position of B. B from left. So when B come from left, origin is left. Moment counterclockwise. B origin from left, B is origin from left, moment counterclockwise. Okay, if C is origin, moment clockwise. C is origin, C from right, moment clockwise. Same goes to column. For column AB and column CD, okay, this is A, this is D. Okay, for AB, origin A, origin A tu from left, A pun left, sama macam D, A left side, D right side. Kita tengok frame ni, A, B, C and D. A and B tu from left, C and D tu from right, A, B from left, C, D from right. So when we put direction, moment direction, we must follow this rule. Okay, when origin come from left, moment is counterclockwise. So for A, moment counterclockwise, but for CD, moment is clockwise. CD origin D, moment is clockwise. Even though bila kita lukis separately, A macam ni, D macam ni, nampak sama kan? Nampak sama bentuk dia kan? But moment equation for A, for this AB and another one is CD, moment equation is not same. Okay, moment equation for AB, moment is counterclockwise, and for CD, moment is clockwise. Okay, kat sini semua kena careful sebab ramai yang bila dia lukis kolom AB and kolom CD, dia pergi buat dua-dua sama. Ini A, ini D. Dia pergi buat dua-dua sama macam ni, or ada yang buat dua-dua sama macam ni, which is wrong. Okay, dia mesti sama ada, dia mesti dua-dua keluar. Okay, sebab apa? Sebab origin from left, origin from right. Okay, dia quite synonym, left dengan counterclockwise and right dengan clockwise. Okay, careful about that. Please careful about that. Ini yang antara benda-benda yang selalu Cik Rosul bagi tahu saya susah hati. Okay, because moment equation ni you put wrong sign convention, your moment equation is wrong. Okay. So even though you don't need to actually show the moment equation, the section, the cutting section, but for you to practice, okay, just draw the diagram. So for AB origin, AB origin A, this is for M naught. 79.17. Okay, this is equal to 0. Limit is 0 to 10. This is 0. Okay, because tak ada horizontal force tadi, right? We have another one, M1 here. Okay, for CD also, CD like this. CD tadi berapa? 145.83. This is 145.83. This is M naught. This is D. This is A. Again, this is also 0. This is also 0. So CD origin D, it is 0 to 4. It is also 0. Okay. For BC origin B, it is 0 to 9. It is 0 to 9. 0 to 9. Okay, kenapa dia 0 to 9? Sebab pada X, pada origin X is equal to 0. So it is like this, UDL, this is M naught, this is A, B, C somewhere here. Okay, AB like this. So we have here 79.17. Okay, so X start from B and at B X is 0. So sini X 0. Dekat sini X 9. Okay, even though yang ni kita tak lukis pun, tapi position dia macam tu. Okay, pada origin X is equal to 0, pada means that pada B X is equal to 0, pada C X is equal to 9. So that is why equation for BC limit dia 0 to 9. Okay, so this is the section. This is the section, so this is 25, right? 25. So we get negative M naught. Okay, tulis betul-betul moment equation ya. Okay, sebab kelas yang previous kelas pun saya jumpa ramai lagi yang tulis tak betul ya. Okay, so when we write moment equation, okay, for cutting section, we take moment at the cutting section at X. Mx is equal to 0. We don't take moment at support. Tadi moment, we take moment at support bila kita nak calculate reaction. Now we want to write moment equation. We have cutting section. So total moment at cutting section, Mx is equal to 0. Total Mx is equal to 0. And this moment is acting counterclockwise because of the origin. So it is counterclockwise, negative M naught. Negative M naught and then plus 79.17x. Distance ini X ya. X. So we get minus 25 times X over 2. Okay. Ada lagi? Tak ada kan? So now we get M naught is equal to 79.17x minus 12.5x square. Okay, so this is the equation. This is the equation for M naught. Member BC, this is for the primary frame. For the primary frame. Okay, so this is M naught. Now we can continue to calculate moment equation for M1. For M1. So M1, what we have is, for M1, we have 0.111. Okay, not affected. But we have 1 here. So this is M1. M1 is moment equation in redundant diagram. M1 at the cutting point. Moment at cutting point we label as M1. Moment at cutting point we label as M1. This is moment redundant. This is redundant value. Redundant value. So again, okay, this is negative M naught plus 1. Negative M naught plus 1 equal to 0. So M naught is equal to 1. M naught is equal to 1. Okay, and then for CD again 0. For CD also 0. And for BC origin B, it look like this. This is M, not M naught, it is M1. M1, M1. So this is M1. 0.111 1 here. Okay, so for this, it is negative M1 plus 1 minus 0.111x. So we get here M1 is equal to 1 minus 0.111x. Is it correct? Okay, write it correctly lah. Okay, this is equation for M1. This is question for M1. Okay. Okay, yang ni saya letak dekat sebelah If you want to refer, please refer. So dia dekat sini. Okay, so this is the table. So most important when we analyze flexibility method for the answer scheme, okay, what you need to show to me is you must have the system, the primary structure and redundant structure. Okay, the structure, you must put the reaction inside. Okay, whether you want to show reaction, how you calculate reaction or not, I don't care. Okay, but because most important is the diagram and the reaction inside. Okay, same goes to moment equation. Moment equation, this is just all the calculation, but most important, I want to see the table consists of moment equation in the table like this. Okay, so we have table. So we have column for M naught, M1 for redundant. This is another one for M naught, one for limit, one for origin, and one for member. Okay. Okay, now we want to continue to calculate displacement. We have two displacement. We have theta 1 naught. It is 1 over EI from 0 to L M1 M naught dx. So this is equal to, okay, for AB, because M naught is 0, so it will equal to 0. CD also. So we only have for BC, and BC is 2 EI. Don't forget we have 2 EI here. We have 2 EI here. So actually kalau you tak nak confuse, you boleh add another one, another column here for EI so that you do not forget. Okay, boleh tambah sini lah. Tambah sini so that you tahulah dia 2 kilonewton, 2 EI. 2 EI . Okay, so how to include? We include 2 EI here, 2 EI. Okay, the limit is 0 to 9. 0 to 9. And the equation, it is M1 M naught. M1 is 1 minus 0.111x and 79.17x minus 12.5x square dx. Okay, please integrate for me this theta 1 naught and give me answer in terms of EI. Okay, I want the theta 1 naught and the answer is in terms of EI. Please integrate. What is the answer? Tiga kosong 9.279. into max. Yang tadi tu berapa? 1 Sini 1. Tolak 0.111 X. 79.17 X. 12.5 X. Twelve point five. 12.5. Divide by 2 please. Divide by 2. 1 over 2. $154.64. Okay, so the answer is 154.64. 154.64 over EI. This is theta 1 naught. Okay, theta 1 naught. So we move to another one. Okay, we have F11. F11 is 1 over EI from 0 to 10 ya. Dia ada 1 kat sini, 0 to 10. 0 to 10 dx. 1 dx. It is 1 square dx plus 1 over EI, 2 EI from 0 to 9. 1 minus 0.111x. 1 minus 0.111x square dx. Okay, now please calculate for me the answer for this F11. F11, what is the answer for F11? Berapa jawapan ni?
Hmm. 11.5.
11.5. Tekan kalkulator lah lagi cepat. 11.5 over EI Okay, 11.5 over EI. So now dah settle yang ni. Okay, what we need to do now is to substitute. Substitute. It is theta. theta 1 naught plus F11 N bukan plus and F11 into the compatibility equation. Okay, substitute theta 1 naught and F11 into the compatibility equation. So the standard form as we have written in the beginning is theta 1 naught plus F11 times MA is equal to 1000 over EI. Okay, so sengaja saya bagi EI kat sini sebab bila dia in terms of EI, we do not need to have E and I value. If the rotation or displacement is given in unit meter or in radian, then you have to assume EI value. If EI value is not given in the question. Okay, so tadi tu berapa? 154.64 over EI plus 11.5 over EI times MA 1000 over EI. So boleh cancel lah. So bila kita solve this, solve for MA. So what we get is MA is equal to 1000 minus 154.64. We divide by 11.5. 154.64. What is the answer? What is the answer? Dia tak cantik, dia tak boleh detect. Berapa jawapan? Okay, 1000 minus 154.64 divide by 11.5. What is the answer? What is the answer? In unit kilonewton meter. 73.4 kilonewton meter. 51. Okay. 73.5 kilonewton meter. Kita dapat redundant. So this is the redundant. This is the redundant. Okay, so once we have the redundant, we can continue. We have another 3. We have another 3 that and we have 2 options. Whether we want to solve it using equilibrium equation, or we can also solve the remaining reaction using superposition method, principle of superposition. And by using principle of superposition is actually easier than using equilibrium equation. Because diagram yang tadi yang awal ni kita dah ada, okay, primary frame and redundant frame. Remember the general equation, the principle of superposition, primary frame plus redundant frame. Primary frame plus redundant frame, and redundant frame, everything inside the system we must times with the redundant value. So means that dua-dua ni dia tambah lah. Tambah and value dekat redundant frame tu mesti kali dengan MA. Means that kalau kita nak cari, for example, kalau kita nak cari AY means 79 ni 79.17 plus negative 0.111. Now dah ada MA, kita kali dengan MA. Sama juga for DY. DY we have 145.83. DY is 145.83 plus positive 0.111 times MA. So everything in the system, everything, not only reaction, internal force, displacement, everything in the system, we times back with the redundant that we take out. Tadi kan asalnya kenapa jadi kali MA ni sebab dia asal MA, yang kita ubah jadi 1 kali MA. So apa yang kita buat dalam redundant frame tu semua due to 1. So bila kita dah dapat balik MA ni, kita bila kita dah dapat balik the reaction, the value semua due to a unique value ni, so of course kita kena kali balik dengan redundant. Jangan lupa kali balik dengan redundant, then only kita dapat balik the value MA, which is equivalent to MA tadi tu. Okay, so yang ni lagi senang compared to kita apply, kita recalculate reaction using equilibrium equation. Okay, anyway ikut suka you lah, which one you comfortable you boleh buat. Okay, for reaction in beam and in frame, you boleh pilih lah whether you want to choose the superposition method or you want to choose equilibrium equation. Untuk beam dengan frame boleh dua-dua. Untuk truss pun sama juga. Untuk truss pun nanti sama, tapi untuk truss kalau you pilih untuk tidak pakai principle of superposition, bila kita nak calculate member forces, dia bukan the best option lah, because you need to repeat the whole process of calculating member forces using method of joint tu, you kena ulang balik semua. Jadi benda tu akan ambil masa banyak lah. So the best way is by using principle of superposition to calculate for the reaction and to calculate for member forces or internal forces. Okay, so finally we have AY 79.17 plus tadi negatif 0.111 kali dengan MA 73.5, so we get AY, and then AX0 of course, so this is DY is 145.83 plus 0.111 kali dengan 73.5. Betul tadi 145? Okay. Okay, then we get all the value. So A X is equal to 0. Okay, cukup 1 jam. And then kita dah dapat all the redundant as well as the remaining reaction in the frame. Okay, cuba calculate, habiskan. Calculate AY value and DY value. Calculate for me 79.17 minus 0.111 times 73.5, and another one is 145.83 plus 0.111 times 73.5. Okay.
AY 71.01.
Okay, kilonewton, and another one 001, bukan 07.
137.67.
DY 1 ke 153? Betul tak saya ambil tadi ni?
153.99.
153.99. Okay, 153.99 kilonewton. Okay, so dah ada semua ni. Okay, so for reaction at A, moment at A, AY, AX, and DY. And actually having all this, we can check for kamera buat hal. Kamera ni buat hal Tapi dengar suara saya kan? Sekejap saya tengok. Something wrong with my external camera. Okay, now saya switch kepada, sekejap Camera is off. Oh, tak apalah, dah nak habis dah kan. Biarlah. Okay, dah nak habis dah kelas. Okay, so dapat So this is how we analyse frame. Actually sama je dengan beam. Nampak tak ada proses tu. Actually dia kalau kita ketepikan step-step yang contoh macam calculate reaction, writing moment equation, dia simple je. Kan, sebab dalam jawapan tu dia mesti ada of course redundant chosen, and then from redundant we directly write the compatibility equation, because compatibility equation ni yang akan guide kita apa kita nak buat next. Okay, so lepas kita dah decide MA as the redundant, daripada redundant chosen tu kita straight away write the compatibility equation. Okay, the compatibility equation. So compatibility equation ni kita dah belajar masa awal-awal hari tu, the derivation. So as I said, derivation tu tak perlu buat every time. Saya hanya tunjuk hari tu how we get the compatibility equation, how we derive that. But by understanding that, we don't have to derive every time. We just need to use it. Okay, and normally by choosing the redundant, after choosing redundant, we can write the compatibility equation, of course all in symbol first. Okay, so but careful, when moment is redundant, displacement refers to rotation. When the dy vertical force or horizontal force as the reaction, so we should have delta as the displacement. Okay, so write the compatibility equation so that dia akan guide. Kita tengok compatibility equation, kita dah tahu dah apa yang kita nak. Okay, so apa step-step yang kita buat after that is just to fulfill the displacement. So inside compatibility equation ada displacement. Okay, then ada formula of displacement. Inside displacement formula ada moment equation. Inside moment equation ada reaction. Ada reaction apa? Reaction in primary structure and reaction in redundant structure. Careful bila ada support settlement mentioned in the question. Kena careful yang tu, because this is one favorite question yang biasanya student should know. Bila ada displacement, dia akan affect the performance, affect the strength, affect displacement, affect everything, affect reaction. So dia akan bagi effect. So normally you have to know lah. You have to know whenever this support displacement, support settlement occur, what happened to the reaction, for example, to the moment. For example, you have to know by comparison lah. Boleh buat comparison lah. Kalau equal to 0, berapa nilai moment. Tengok lagi kecil ke lagi besar, boleh tengok yang tu comparison. Because sometimes dalam exam kita akan tanya that comparison. Without support settlement, apa nilai moment at A? With support settlement, apa nilai moment at A? Mana yang lagi kecil, mana yang lagi besar? Dan explain kenapa. Kenapa kalau ada support settlement nilai dia lagi besar? Contoh. Okay, so you kena ada all the reason. Okay, all the reason kena ada. So kena faham konsep-konsep effect from support settlement, effect from flexural rigidity, effect from material, effect from the cross section area, the size of the element. So all these effect boleh jadi soalan-soalan yang akan ditanya dalam exam, yang mana you have to explain, you have to justify, you have to to discuss. Okay, so that's all. Ini je. So skip unimportant step, so you akan nampak dia pendek lah. Kalau you tengok, kalau you tak skip semua everything you nak tulis, you akan nampak dia sangat banyak. Okay, so equation ni sebenarnya yang ni juga tak perlu tulis. Okay, cuma tadi first time saya tunjuk dulu lah. Ni this is the process kan. This is the equation kan. And yang ni juga tak payah tulis sebab you terus key in dalam calculator moment equation yang dah ada dalam table. Saya tak nak you tulis sebab bila kita tulis, sometimes bila kita rewrite tu kita tinggal sign. Rewrite tu kadang-kadang negatif jadi positif, positif jadi negatif. Kadang-kadang tertulis nombor lain. So kita reduce mistake. Kita reduce mistake ya dengan cara kita tak tulis banyak kali. Okay, bila nak integrate kita dah tahu dah it is M1 M0, it is M1 M1 M0. So gunakan these two equation terus key in dalam calculator. So tak payah tulis yang ni. So tak payah tulis ya, tak payah tulis. So that kita akan reduce kita punya mistake. Okay, so kita jumpa hari Jumaat ni. Okay, get ready around pukul 10.30 dekat bilik seminar. Saya dah booking bilik tu. Around 10.30 lah, paling cepat 10.30. Kalau terlambat maybe pukul 11 lah, insyaAllah. Okay, so hari Jumaat ni kita akan buat another one example, frame example, but kita focus on two redundant. Okay, so that's all for tonight's session. Thank you very much. Okay, that's all. Assalamualaikum
Thank you,
warahmatullahi
Dr.
Yeah.
Thank you, Dr.
Assalamualaikum.
Waalaikumsalam.
Salam.
Okay, madam.
Okay, thank you.